So the rate at which this is a question application of differential equation again. The rate at which a substance evaporates is K times the amount of substance which has not yet evaporated. So then I go, because okay, for doing these questions we like to convert every single English statement as soon as it is seen into a kind of mathematical equivalent. So immediately I want to write some equation that describes this English statement. So whatever I want to know what stands for the amount of substance. So if the initial amount of substance was A and the amount which has evaporated at time t is X. So that means write down a differential equation involving X and T, solve it to give X in terms of, so X is the amount which has evaporated. Okay, so that means what is the amount of substance remaining? The amount of substance remaining at any time is A minus X. Okay, then the rate at which the substance evaporates, so dx dt is equals to K times the amount of substance which has not yet evaporated. So yep, so this is the amount of substance that has not yet evaporated, this is the amount of substance that has evaporated, and this is the amount, initial amount. So initial amount minus the amount that has evaporated is the amount which has not yet evaporated. Okay, let's put it simply. So if the initial amount of substance was A, write down a differential equation involving X and T. So that this is the differential equation, and solve it to give X in terms of A, K, and T. So then we will solve this. Okay, we'll solve this by taking I'll bring 1 over A minus X to the side of the X, and multiply, bring all the T over to the right hand side, and this is solving this. So then we have we can change this to -1 and put a minus outside, so that now the numerator is the derivative of the denominator, and we can just apply the integration techniques. Whenever the numerator is the derivative of the denominator, we can just ln the modulus of the denominator, right? So then this would be kt plus c, where c is any arbitrary constant. You need to write that down in an exam. So where c is an arbitrary constant. Alright, and next I'll just bring minus over to the other side. So a minus x equals to e minus kt minus c. Okay, because minus will bring over first, get minus kt minus c, and then we'll exponential both sides to get rid of the logarithm here. So then we will have this, but a minus x is always a positive number, because x could not be, a is initial amount of mass which is positive number, and x could never be more than a, because you cannot evaporate a substance more than the amount of substance that is present. So then we have to find this, we just bring the a. Okay, this one, e minus c, this is equivalent to e minus kt multiplied to e minus c, and if I let e minus c be b, so I will let e be e minus kt, where b equals to e minus c. Alright, and then we will have, okay, so that means a, bring this over, minus b e minus kt would be equals to my x bring over to the right hand side. So that would be an equation involved. So we have this, and I'm supposed to solve it to give x in terms of a, k, and t. So how do I solve this equation? We use this fact that when t equals to 0, x is equals to a, right, the original amount of substance present, and that will give me, when t equals to 0, this entire term here would be 1, because e to the power of 0 is 1, and that means a minus b equals to a. That means b just equals to what? Oh my god. So this one is to my a minus b equals to a. That is a bit of the strange. So that means b equals to, that is a bit strange, right? I'll just check my working to make sure that nothing is wrong. So here we have, alright, minus this one, 1 over a minus x. The rate of change of the amount of substance evaporates is k times the amount of substance which has yet to be evaporated, which is a minus x, where k is a constant, was a. So when t equals to 0, x equals to a, that's correct. And the amount which has evaporated at time t is equals to x. So when I integrate this, I should get, right, it is correct, 1 over equals to, so then this is correct as well, and this is so. Then when I take negative and exponential, that is be minus kt, okay. Then a minus be minus kt equals to x, okay. When t equals to 0, no, when t equals to 0, x does not equals to a. This is my mistake here, right? Because x does not stand for the amount of substance in the beginning, rather x stands for the amount of substance that has evaporated. When time equals to 0, the amount of substance that has evaporated is equals to 0. That means I have changed this equation, t equals to 0, so a minus b equals to 0, therefore b is just equals to a. This seems like looks more reasonable. So then we have this equation in terms of a, okay, a, then this equation becomes a minus a e minus kt equals to x, where x is the amount of substance that has evaporated. So now we have solve it to give x in terms of a, k, and t. So this is the solution, or we can rewrite it as 1 minus e minus kt as well. So sketch the graph of x against t for the case k equals to a equals to 2. Alright, so that means they want us to sketch the graph x equals to 2, 1 minus e minus 2t, right? They want us to sketch the graph, and then ask us to show that the time taken for half the substance to evaporate is half ln 2. So time taken for half of the substance to evaporate, that means initially the substance is a, so half of the substance to evaporated is half a. For half amount evaporated to be half a equals to 2, 1 minus e minus 2t, and this will become a equals to 4, right. Wait, so this a is 2 now, okay, and wait, so that means what they want, right? Give me a minute. So then this one, what they want half a, and a is in this case is already 2, okay, and half of the amount should be evaporated, so that equals to 2, 1 minus e minus 2t. That is, so because a equals to 2. Alright, then this would be 1 equals to 2, 1 minus e minus 2t, and this would be half equals to 1 minus e minus 2t, right? And then this would be half again, you get e minus 2t, and that will be minus 2t equals to ln half, and then t equals to minus half ln half. Alright, and that is just negative. I can bring it over up, right? So this negative can bring up to this power of this half, and that will give me half ln 2, which is the answer over here. So back to drawing the graph, we just need to brought this inside the graphic calculator, and we will be able to get the graph. Alright, and the graph would be in terms of x and t. Okay, so let's see what the graph looks like. And clear 2 1 minus e, so power of minus 2t. Okay, and we get the graph that looks like this. When t goes to 0, we know that this is 1, so 1 minus 1 is 0, so x equals to 0, and it goes up like this. So but where is the asymptote, right? When t approaches infinity, this term becomes 0, because e to the power of negative infinity is 0, so we have 2. So then that means the amounts will converge at 2. It will never fully evaporate, but it will evaporate and amounts close to 2 as t approaches infinity. So this is the graph, right? So that's all for this tutorial.